Welcome. This section is going to talk about, or this video is going to talk about finding the inverse of a matrix and then using the inverse of the coefficient matrix to solve a system of equations. First, we need to understand what we mean by the inverse of a matrix. So right here, two n by n matrices are inverses of one another if their product is the n by n identity matrix. Not all matrices will have an inverse. In fact, a square matrix, so an n by n matrix, a square matrix has an inverse exactly when the determinant is not 0. So if the determinant is 0, there's no inverse. If the determinant is any other number, there will be an inverse. And the notation for the inverse that we need to be aware of is a with the -1. So we read this. This is read A inverse, or the inverse of matrix A. All right, so this idea right here is going to be important. Determine if the matrices below are inverses of each other. If their product is the identity, they are. So what we need to do is we need to show that A times B equals the 2 by 2 identity matrix. So that's what we need to show. If it comes out to anything other than the identity matrix, they are not inverses. Now, if your teacher wants to have you show the other order, then that's up to them. But really, if the product in one order is the identity, then the product in the other order is also the identity. Remember, usually when we switch the order of multiplication, usually A times B and B times A are not going to be the same. But if they multiply together to create the identity in one order, it will be the identity in the other order. So I'm just going to check one order. I'm just going to check to make sure that A times B is the identity. All right, so I'm going to write out all the steps here. I'm going to write them out, 11, 2, -5, -1, and I'm going to multiply that with matrix B. Let's review how that goes. So we have a 2 by 2 multiplying with a 2 by 2. The middle numbers match. Use the outside numbers. Use these numbers to tell you what the size of the product is. So we have a 2 by 2. And what I then have is I have 4 spots that I have to fill. 2 rows, 2 columns. So let's remember how we find these different entries of the matrix. So remember so if I want the entry in the first row, first column, I take the first row and multiply it with the first column. Now, how does that work? Well, we take the 11 times the 1, first number here, first number there, and then we add, so we're going to move across the row and take the -5 and multiply it with the +2. So we go across the row, down the column. Okay, I'm going to do the next one a little faster because we should already know how to do matrix multiplication. So now I am in row 1, column 2. So I'm going to use row 1 and column 2. So I'm going to do 11 times -5 plus -5 times -11. Okay, I'm going to switch to blue and do these last ones faster. So I'm in row 2, column 1. So I'm going to do row 2 with column 1. So I'm going to do 2 times 1 plus -1 times 2. And the last one that I need to do is 2 times -5 plus -1 times -11. And let me write that a little bit smaller inside there. So we're doing row 2, column 2. So I take row 2 and I combine it with column 2. How do we combine them? 2 times -5 plus, walk across the row, do -1 times -11 as we walk down the column. Okay, what do we now have? We have 11 plus -10, which is 1, negative 55 plus 55, which is 0. 2 plus negative 2 is 0. Negative 10 plus 11 is positive 1. So they are inverses, and we have verified that. Okay, now let's talk about how to find the inverse of a 2 by 2 matrix. So this is the next idea. How to find the inverse of a 2 by 2 matrix. There's a formula that we're going to memorize to do this. So if we have a matrix A, here's matrix A. What we do is we switch the A and the D, and we put a negative in front of the B and the C, and we divide everything by the determinant. So we're going to write it this way. This is a little formula we want to remember. So notice that's 1 over the determinant of A. It's 1 over the determinant of matrix A. And then we've switched the A and the D. We changed the sign on the B and the C. Change them to the opposite sign. That's our formula. All right, so for these two examples, we're going to find the inverse of each matrix if possible. So we're going to first of all find the determinant of matrix A. So the determinant of matrix A is going to be 7 times 5 minus 2 times 17. That's 35, take away 34, which is 1. So the inverse of matrix A is going to be 1 over 1, which is just 1. And then we switch the 5 and the 7. So these two switch. Change the sign on the other two. So the negative 2 and the negative 17. And since, let me fix that so it looks a little better. So since 1 over 1 is just 1, my inverse matrix is 5, negative 2, negative 17, and positive 7. And we are done. All right, let's do the second one. B. First thing we're going to do is calculate the determinant of B. So we'll do 4 times 6 minus negative 5 times negative 9. Just be really careful with the signs here. That's going to be 24. Take away 45. That is negative 21. So our inverse matrix, B inverse, is going to equal 1 over negative 21 times, we're going to switch the 6 and the 4. These guys switch. 6 and 4 switch. Change the sign on these guys. So that becomes a 5 and a 9. Okay. And then we're going to distribute or multiply that scalar through because the negative 1 over 21 is a scalar. So I have negative 6 over 21. Let me make that a little bigger for my fractions. Oops. Negative 5 over 21. Negative 9 over 21. And then negative 4 over 21. Now, if you're allowed to leave fractions unreduced, would be okay there. But the negative 6 over 21 will reduce to negative 2 over 7 because I can divide out a 3. Negative 5 over 21 does not reduce. 9 and 21 are both divisible by 3, so I can take out a 3 and make that negative 3/7. And finally, negative 4 over 21 does not reduce. It's already in lowest terms, so there's our inverse matrix. That's B inverse. Now, what we're going to do for the remainder of this video is we're going to talk about how to use the inverse to solve a system of linear equations. So let's talk about how that works. So what we're going to do is we're going to write this system of equations. So here's our system. We're going to write that system of equations in terms of matrices. And in terms of matrices, what it looks like is A times X equals B, where A is the coefficient matrix. So notice what we have in matrix A. We have the coefficients of X in the first column. There they are. I'm going to erase those. I'm just pointing out where they are. And then in the second column, we have the coefficients of b, or y, sorry, the coefficients of y. So the b and the e. See them right there? So you have the coefficient matrix. We call that the coefficient matrix. All right? And then notice matrix X contains the variables. So we call that the variable matrix. So this matrix right here contains the variables X and Y. And then the matrix B contains the constants, the C and the F, the numbers that are on the other side of the equal sign, the constants. Oops, I thought I had clicked my eraser. Apologies. All right, I want you to stare at that for a minute, make sure that equation really works. Actually, I think I should write it over here. So if we do A times X, we have A times X plus B times Y. Remember, across the row down the column. So we have AX plus BY, and if that's going to equal the matrix on the right-hand side, that would have to equal the C. And then when we do the second row, multiplying with that, we have DX plus EY. If that's going to equal the matrix B, then that has to equal the F. So we can write a system of equations in terms of matrices. Then what we will do is notice that if we multiply both sides of this equation by the inverse, I should still have an equal sign. But this product right here, now notice I multiplied on the left. That's very important because order matters when we're multiplying matrices. That's the identity. And remember, the identity matrix acts like a 1. So when I multiply the identity matrix with the matrix X, I just get X. So X equals A inverse times B, which is this equation that we have right here. X equals A inverse times B. You're going to want to remember that. Okay, so what we're going to do next is we're going to use this technique to solve a system. So here we go. Our matrix A, let's write down what our coefficient matrix is. So we have the coefficients of X and Y in the first equation, coefficients of X and Y from the second equation. That's the coefficient matrix. So in the first column, you have the coefficients of X. So these are the coefficients of X. These are the coefficients of Y. So we call it the coefficient matrix. So what we're going to do is we're going to calculate the determinant of matrix A because I need the inverse of matrix A. So we'll calculate the determinant. So we're going to do 2 times 2 minus 1 times 5. Or 5 times 1, same thing, right? So we have 4 minus 5, which is negative 1. So our inverse matrix, let's write down what it is. We'll just write down that X which is this matrix right here. Maybe I'll write it over here. X equals, I'm going to do A inverse. Now remember what the inverse is. We do 1 over the determinant of matrix A. Then we're going to switch the 2 and the 2. We're going to change the sign on the 5 and the 1. But we need to multiply that with the matrix B. So we've got our A inverse times B. What's the matrix B? It contains the constants. That's the negative 2 and the negative 3. Okay? So what we're now going to do is we're going to perform this multiplication. So I'm going to hold that negative 1 out here for a minute, and I'm just going to do all the multiplying. So I have 2 times negative 2. Remember, across the row, down the only column that I have. So 2 times negative 2 is negative 4. Maybe we'll write it in here. 2 times negative 2 plus negative 5 times negative 3. All right. And then we're going to do the bottom row. So negative 1 times negative 2 plus 2 times negative 3. And we're going to simplify that. Remember, we have to distribute a negative when we get finished. That's negative 4 plus 8, which is 4. And then 2 plus negative 6 is, I think I did something wrong. Did I do something wrong? Yeah, I did. That's negative 4 plus 15, which is 11. Okay, so in that top, I have negative 4 plus 15, which is 11. And then 2 plus negative 6 is negative 4. Okay, we're going to distribute the negative, and what we have is negative 11, positive 4. So this is our x, and this is our y, right? Remember what it was, x and y. So I really don't need to write those guys. So negative 11, positive 4. Check your answers. You can do that. Check them in the original system. Oops. Went too far. Scrolled too far. Right here. So if I replace the x with negative 11 and the y with a positive 4, you get negative 22 plus 20, which is negative 2. That one works. If I put in negative 11 for x, positive 4 for y, I get negative 11 plus 8 equals negative 3. It worked. Okay, let's flip to the back of your notes. We're going to look at the other 3 examples that we have. We will probably go through them a little faster. We're going to solve each of these systems using the same technique. So first things first, we're going to write down the coefficient matrix. So 1 and 2, coefficients of x and y. 3 and 5, coefficients of x and y. We're going to calculate the determinant of matrix A. Let me fix that a little bit. So I'm going to do 1 times 5 minus 3 times 2. So that's 1 take away 5. Whoops. Engage the brain. That's going to be 5 take away 6. 1 times 5 is 5. Take away 3 times 2. So 5 take away 6, which is again negative 1. Well, this is getting interesting. So what we have is xy equals A inverse. So how do we find A inverse? A inverse is going to be 1 over negative 1. Switch the 5 and the 1. Change the sign on the 2 and the 3. And then we have to multiply that with the constant matrix. Almost said coefficient. Matrix that contains the constants. So there's the A inverse times B. Let's do the multiplying. And then I'll distribute a negative at the end, or a negative 1, whatever. 5 times 5 is 25. And I have 25 take away, or 25 plus negative 28. And then I have negative 3 times 5, which is negative 15, plus 14. And then we'll distribute the negative 1. So I have negative 1 times negative 3 that I'm going to have to do. And negative 1 times negative 1. So we have 3 comma 1. That's our x and our y. So the solution is 3 comma 1. Done. Let's check it in the original equation. So if I put in the original system, if I put in 3 for x and 1 for y, I have 3 plus 2 is 5. In the second equation, I have 9 plus 5 is 14. It worked. We did good. Okay, next example. Solve the system. Same thing. Remember, if your determinant is 0, we can't use this technique. There might be, if the determinant is 0, there might be infinitely many solutions, or there might be no solution. We have to study the system a different way. So first step, write down your coefficient matrix. Second step, find the determinant of your coefficient matrix, because we need A inverse. We need the inverse of the coefficient matrix. So let's see what we have. We have 4 times 3, which is 12, minus 5 times negative 2. So we have negative 12 plus 10, which is 22. That's weird, but it is correct. So now what we're going to do is our solutions x and y, or our solutions, yeah, that's a good way to say it, x and y are going to be calculated by taking A inverse. So we need 1 over 20, 1 over the determinant, times the matrix that we get by switching the 3 and the 4, changing the sign on the negative 2 and the positive 5. So that's our A inverse. This is our A inverse. Now we have to multiply that with matrix B, which is the constant matrix, contains the 0 and the negative 11, right? Okay, I erased a little bit too much. Let's do the multiplication. So I have 1 over 22, and here's why I always leave that 1 over the determinant out in the front, because it's going to be easier to do the matrix multiplication without the fractions. So I keep that 1 over the determinant out in front here until I have finished the other multiplication. So we have 3 times 0, which is 0, plus 2 times negative 11, which is negative 22. And then when I do the second row and combine it with that one and only column I have, I'm going to have negative 5 times 0, which is 0. So I'm going to have 0 plus 55. Oops. I forgot to move across the row, didn't I? So negative 5 times 0 plus 4 times negative 11. That's negative 44. Okay, now what do I have? I have negative 22 divided by 22, because multiplying by 1 over 2 is the same as, or multiplying by 1 over 22 is the same as dividing by 22. 44 divided by 22 is, rewind, struggle is real. That's a negative 1. Negative 22 divided by 22 is negative 1. Negative 44 divided by 22 is negative 2. Okay, so solution, x is negative 1, y is negative 2, and we are finished. Plug them into the original equations. Make sure they work. So check them back in the original equations, right here in the originals. Check them in there. Okay? We'll just check them in there. 4 times negative 1 is negative 4. Negative 2 times negative 2 is positive 4. So I have negative 4 plus 4, which is 0. 5 times negative 1 is negative 5. 3 times negative 2 is negative 8. When I add those, I get negative 11. It worked great. We have one last example. Solve the system. Okay, same drill. We're going to write down our coefficient matrix. Lots of positives in this one. Everybody's positive. The determinant of matrix A is going to equal 3 times 2, which is 6, minus 4 times 2. So we get negative 2. That's the determinant. So what we're going to have is the x, y. Our solutions are going to be calculated by taking 1 over the determinant, because I need A inverse, and I'm writing down A inverse right now. Switch the 2 and the 3. Switch these guys, right? Change the sign on the other ones. So we have negative 4, negative 2. And we need to multiply that with the matrix B that contains the constants. Okay, so we're doing A inverse times B. But I'm going to hold that 1 over determinant out in the front, multiply it last so I don't have to deal with any fractions. There would be a 3/2 in there, and it's just going to be easier if we keep it out there till the end. All right, so what do we have? 2 times 20, which is 40, plus negative 4 times 12, which is negative 48. So that's going to be negative 8. As you go through, figure out what process works best for you. Negative 2 times 20 is negative 40. And then 3 times 12 is 36. Add those up, we get negative 4. Oops! Lost my negative 1/2. Don't do that. Okay, I still have to multiply by negative 1/2. So what do I have? I have positive 4 and positive 2. Let's check that in our original system of equations. Check it in the system of equations that we started with. Okay, so go back to your system of equations. Check and make sure it works. So 3 times 4, back to your original. Here's the original system of equations. 3 times 4 is 12. 4 times 2 is 8. We add those together, we get 20. 2 times 4 is 8. And then add 4, we get 12. It works. We're done. Have fun with the assignment.